Hi and welcome to the fourth class on time, speed and distance. So we started this concept some time back and I told you that time, speed and distance is the most important chapter, most important concept for any competitive exam because this will give you a bunch of questions for sure. So in the first class, we had introduced to you the concept of time, speed, distance and their interdependency. If time is constant, speed and distance are directly proportional. If speed is constant, then distance and time are directly proportional. If distance is constant, then speed and time are inversely proportional. We started with that. Then we went on to calculate average speeds, and we saw that average speed is not the average of speeds. Then in the second class, we introduced to you the concept of relative speed, and we did a fair number of questions on that. And in the third class, we did problems on races and escalators. Now in this class, we'll continue with the concept of relative speed and we are going to look at boats and streams. Another very interesting application of the concept of relative speed is boats and streams. So let's jump in right away. Okay, so let's say that you have a stream. Stream basically means what? A river. Okay, so there is a stream and a stream will have its own flow. The stream will move, right? So in fact, the rivers get formed in the mountain and moves to the plains, right? So they come from top and they move downward. So in fact, a river is always said to flow downstream. Okay, so this is a term, downstream. So the river will always flowing like this. Okay, and if I have a boat in this river and I can row this boat, I'll have my own speed. So let's say that speed of the boat in still water is b meters per second. So this has a speed of b meters per second, and speed of the stream is s meters per second. Stream direction of the flow of the river is defined, but boat obviously can move either way. Okay, so then we say a boat is said to go downstream if it is moving along the direction of the stream, because stream, I told you, will only go downstream. If boat is also moving in the same direction, then it is said to go downstream. And then obviously you can see that the river is going to assist the boat. In fact, if the boat is not moving at all by itself, still it will go at a speed of s, right? Because the flow of the river will make the boat also flow along with it. Okay, so but if the boat also has its own speed of b, then the final speed of the boat is going to be b plus s, because the river is going to help it, right? So it will be b plus s meters per second. Okay, again, this does not go contrary to your relative speed concept. You might say, why are we not subtracting the speed? But again, note that the absolute speed of the boat is b plus s. The absolute speed of the river is s. So the relative speed of the boat is b, which is b plus s minus s. So that's where b comes from. So this is the absolute speed and this is the absolute speed. Okay. Similarly, if the boat is going up at the same speed of b meters per second, then first thing, so for the boat to move up, obviously it should have speed greater than that of the river. So b has to be greater than s. Otherwise the boat will never move up. The river will always pull it down. Okay, so if b is greater than s, then the final speed of the boat is going to be b minus s meters per second. This is the upstream speed, right? So this is the upstream speed of the boat. This is the downstream speed of the boat, right? I hope these two terms are clear. Okay, so downstream is b plus s, upstream is b minus s. Okay, so this is the first concept to understand. Very, very simple. Okay, so here we have introduced these two terms. So now if I have this, so upstream speed or downstream speed I call as b plus s, upstream speed I call as b minus s. If I add both of them, I will get d plus u is equal to 2b, or I can say that the speed of the boat is equal to downstream speed plus upstream speed by 2, which is my first equation, speed of the boat. So if you know the downstream speed of the boat, if you know the upstream speed of the boat, you can add both, divide by 2, and you will get speed of the boat. And in case I subtract these two, then I'll get d minus u is equal to 2s. b will get cancelled, I'll get 2s, or s is equal to d minus u by 2. So this is the speed of the stream. That is what is given to us. Okay, again, very basic equations, very basic formulas. You need not know them, need not remember them. We can do it very, very simply from the concepts. Okay, one more concept that we use, or one more formula that we use, again, may not use, not a problem. We can do directly also. If time taken by a boat to cover a distance upstream is t up, and to cover the same distance downstream is t down, then speed of the boat upon speed of the stream, or b upon s, is equal to t up plus t down upon t up minus t down. The distance has to be same both ways. Cover the same distance. The distance that it has to cover has to be same. Okay, so there again we can just look at the time up plus down, time up minus down, and that will give us the ratio of the speed of the boat and the stream. Okay, so let's jump into some questions and then understand this better. Okay, so first question. The speed of a boat is 16 kilometers per hour in still water. This still water is important. That means it's the actual speed of the boat in case river is not flowing. So b is equal to 16. Speed of the stream is given to us as 4. Okay, everything is in kmph. The distance between point x and y is 120 kilometers. Is 120 kilometers. How long does the boat take to travel from x to y and come back? Now I don't know whether x to y is downstream or upstream, but that does not matter because one way will be downstream and one way will be upstream, right? Whichever way. So to go downstream, time taken will be b plus s, right? The river will help, it will move faster, it will take lesser time. And to come upstream, the river will actually act against you and you'll slow down and you'll take more time. Okay, so if I write in terms of b, it will be b minus s. So that gives me 120 upon 16 plus 4 plus 120 upon 16 minus 4. So 120 upon 20 is 6 and 120 upon 12 is 10. So you can see downstream it takes only 6 hours, upstream it takes 10 hours because downstream it has a speed of 20. The boat moves at a speed of 20. Upstream it moves only at a speed of 12. Okay, because the river is resisting the movement. So total time taken is 16 hours. Answer is 16 hours. No formula used, done purely from the concept. Okay, so time taken for the boat is 16 hours. I hope we are clear. Very, very simple question. Okay, which way was downstream, which way was upstream, we did not know, but we just assume that one is downstream and one is upstream. Distance is same, so it does not matter. Okay, so downstream time taken is this, upstream time taken is this, and then we put the values and we have got the answer. Okay, let's look at another question. A boat goes 30 km upstream, 44 km downstream in 10 hours. Okay, so we do not know the speed, but we know the distance. Total time taken is 10 hours. 44 kilometers upstream, 30 kilometers upstream. So 30 upon b minus s plus 44 kilometers downstream. This is going to be first equation. And then second equation is in 13 hours, it can go 40 kilometers upstream and 55 kilometers downstream. These are my two equations. Right. Now if you see, we have reciprocal, and in reciprocal we have b plus s and b minus s. So for the sake of simplicity, what we had written earlier, b plus s is the downstream speed, let's call it d, and b minus s is the upstream speed, let's call it u. And so this will become slightly simpler to look at. So I have 10 is equal to 30 upon u plus 44 upon d, and 13 is equal to 40 upon u plus 55 upon d. Okay, one of these I want to get cancelled, so let's say I multiply the first one with 4 and the second one with 3. So what do I get? 40 is equal to 120 upon u plus 44 into 4, 176 upon d, and 13 into 3, 39 is equal to 120 upon u plus 165 upon d. I subtract them, minus, 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 this gets cancelled. 1 is equal to 176 minus 165, that is 11 upon d, or d is equal to 11. So this is equal to 11, right? Okay, let's put that in the first equation. So 10 is equal to 30 upon u plus 44 upon 11, which is 4. So 10 minus 4, 6. 6 is equal to 30 upon u, or u is equal to 5. So I get this. Okay. Then if you remember, we had written a formula for this one. Yes. So I can use this. Okay. Or you can go from basic principles also. So my boat speed is equal to d plus u by 2, and my stream speed is equal to d minus u by 2. So this is equal to 11 plus 5, 16 by 2, which is 8, and stream is 11 minus 5 by 2, which is 3. Okay, kilometers per hour. The data is in kilometers per hour. Okay, or you can simply add the two equations here. You will get 2b is equal to 16, same thing. Okay, so the speed of the boat in still water is 8 kilometers per hour. Okay, so you just have to be good and clear with formation of the equation, and if you are good with that, you will not face any problem or any challenge whatsoever. Okay, let's go to the next question. The speed of the boat in still water is 6 kilometers per hour. So b is equal to 6. Stream is 2 kilometers per hour. The boat goes a certain distance down the stream and comes back upstream to the same place from where it started. In the journey, the boat didn't stop at any point. Find the average speed of the boat in the entire journey. Okay, so this is the averages concept, if you remember, we had done earlier. Okay, distance covered is same. So distance covered is same. Downstream, it will go at a speed of 6 plus 2, which is 8. And upstream, it will go at 6 minus 2, which is 4. Okay. Now, you may make the mistake and say that the average speed is 8 plus 4 by 2, which is 6 kilometers per hour. But that we had learnt, if you remember, in the averages concept, that is a wrong method. If one part of the distance journey you cover at speed, A speed, and same part return you cover at B speed, then your average is 2AB upon A plus B. Do you remember this? So it means 2 into 8 into 4 upon 8 plus 4, which is 16, 64, 64 upon 12, which is 6 and 32, which is 3 and 16, 16 by 3, 5, 1 by 3 kilometers per hour. And if you remember, I told you that this answer will always be less than the arithmetic mean. Concept wise, if you want to understand, let's assume the distance is d. So my average speed is your total time taken, total distance. It is total distance upon total time. Okay, total distance is d while going and d while coming back, so 2d. Total time, now while going, time taken was distance upon speed, and while coming back it is distance upon speed. So this will be my equation. So 2d upon 8d plus 2d, so it is 2d into 8 upon 3d, d gets cancelled, it is 16 by 3. Okay, and that becomes your answer for this question. So this is a fairly simple question, but you have to remember the concept of averages to get this right. Okay. A boat takes 6 hours to go upstream and come back 6 hours to go downstream and come back upstream in 12 hours. This is where we had given you this formula. If you remember this formula that we had written down. So it comes back the same distance. So basically speed of the boat to speed of the stream is t up plus down, t up minus down. So I can apply this. So let's solve from the formula, then we'll solve from the concept. So boat upon river or stream is equal to 12 plus 6 upon 12 minus 6, which is 18 by 6 or 3:1. So the ratio is 3:1. Okay, so this directly from the formula. But in case you do not know the formula, absolutely not a problem. Distance is same, so time taken to go downstream is 6 hours. So 6 hours is equal to distance upon boat plus stream, and 12 hours is equal to distance upon boat minus stream. Right, that is what we have. Let's divide both of them. D gets cancelled. You get 6 by 12 is equal to b minus s upon b plus s. Okay, so let's cross multiply. 6b plus 6s is equal to 12b minus 12s, or 18s is equal to 6b, or b by s is equal to 18 by 6, which is 3 by 1. So that is what gives you the answer for this question. Okay, so very basic formulas. If you ignore them, if you don't know them, absolutely not a problem. You can solve without them as well. Fine. Okay, great. Let's move forward. And we have this question. A man rows 10 kilometers upstream and comes back to the same starting point in 55 minutes. If the speed of the stream, then find the speed of the boat. Okay, so 55 minutes is the time taken, and speed is in kilometers per hour. So let's keep this in hours. So 55 by 60, which is 11 by 12 hours, is the time taken to go 10 kilometers upstream. So 10 upon boat minus stream plus 10 upon boat plus stream. This is what my equation is going to be. So this, you can see, this will become a quadratic equation. Okay, but let's solve this. So 11 by 12 is equal to 10. Let's keep 10 out. We have b plus 2 plus b minus 2, and below we have b square minus 4. Okay, so 11b square minus 44. Now b plus 2 minus 2 will get cancelled. You will have 2b into 10. You will have 20b, 20 into 12. You will have 240b. Okay, so the equation will be 11b square minus 240b minus 44 is equal to 0. Okay, so what quadratic equation can we make with this? 11b minus something into b minus something should be equal to 0, right? Or one will be minus, one will be plus. Okay, so you would be aware of how to make quadratic equations and how to factorize them, but just to revise here, this equation when you have, we look at A and C, that is 11 into 44 is 484. Now I have 240 here. 242 into 2 can give me 484. So what I'll do is, I will write 11b square plus 2x minus 242x minus 44 is equal to 0. Okay, so I'll take, it is b, sorry, not x, it is b. So if I take b out in the first one, 11b plus 2 minus, similarly in the second one, I have 242b plus 44. Okay, so here I will take 22 out, so 22, so it will become 11b plus 2. So net I have 11b plus 2 into b minus 22. That is what I have. So 11b plus 2 into b minus 22 is equal to 0. So b is either 22 or b is equal to minus 2 by 11. Minus 2 by 11 is a negative speed. Boat obviously cannot have a negative speed, so that is ruled out. So the speed of the boat is 22 kilometers per hour. So b is equal to 22 kilometers per hour. This will become your answer for this question. Okay, so I hope we are clear. All using basic concepts. There's nothing extra you have to do, just that in this question a quadratic equation will have to be formed, which is this, and this how this will be solved. In case you have not done quadratic equation so far, don't worry, we'll take up it in one of our later classes, and we'll tell you how to factorize and how to get the values from these equations. Okay, so that brings us to the ends of boats and streams, which is what we intended to cover in this class. So please revise this, please do these questions, do some more questions, and then in the next class we'll move on to circular tracks, a very interesting concept. So we'll look at circular tracks and we'll solve a lot of questions, and that has a lot of concepts also. So we'll look at those concepts and we'll solve questions on circular tracks. Okay, thank you so much, take care, bye bye.